Now, carrying on with some of the videos that I've been releasing lately, I've been shooting some videos around some of the best antennas that are very easy to build, and I've been calling them antenna basics. And to build them, we're just going to use common materials that you can find around most people's houses. For instance, you don't need anything specialized apart from the connectors, really. And we're going to be building a single biquad element antenna. This is going to be for 2.4 gigahertz, but you can use one of the wavelength calculators online and build it for any frequency you like, really, as long as it fits inside of the case. And what makes this video special to me, and is quite unique, I haven't seen anything like it in the last 16 years since I first saw this, is we're going to be using a CD case. In particular, this is a 10-pack case here to house the biquad elements themselves. It makes a really nice package for a single element biquad inside this case. And I've built many biquads over the years on this channel, and this is by far one of the cheapest, simplest, and a really effective case to protect the elements on your biquad antenna. Now, the idea of putting a biquad inside a CD case like this is not my idea. I think I first saw this around 2007, maybe a little bit earlier, I can't remember now. But it was a guy called Fox, and he's still on YouTube, although he hasn't released anything in over 2 years now. I hope he's okay. But he was putting together a very early show and releasing them to YouTube and other platforms at the time. And this is a build that he did. This build's not going to be exactly the same. I've just changed a few things, components that we can get hold of today. For instance, I'm using an SMA connector. He used an N-type connector, which I think is too big for something that's going to be portable. I tend to use N connectors for something that's going to be a permanent installation. But basically, it's going to be using the same techniques as he did, but I've just modernized it a little bit. But he's definitely the one that came up with this idea, as far as I'm concerned at least. Is the first guy that I saw that came out with the idea of using a case. Now, keeping it together with the spirit of being basic, as I said, most of these things can be found around most homes, but the only thing you're really going to have to buy is the SMA connector. Now, this one is an SMA connector, but we actually need an RP SMA connector for this build. Unfortunately, I haven't got any RP SMA connectors, so I'm going to be slightly modifying this one so we can use it in this build. But if you look up RP SMA connectors on eBay, 4-hole panel mount like this, you can find them, although they're a little bit rarer. There seems to be a bit of a shortage at the minute for the RP ones. There do seem to be more of the SMA ones, but you're looking for the one where it's a sticky in a bit female one, as opposed to the sticky out bit, which is the male one. Now, for the elements themselves, we're going to be using copper wire. This is some earth wire that I've got here. We're going to be using one of the strands out of this. I'm going to be straightening it out and using this for the main driven elements of the biquad. Pretty soft stuff, this, really delicate. I mean, it's not going to be an issue because we're going to be protecting it inside the case, but if you weren't going to use a case, you want to use something a little bit thicker, not quite as delicate. But just get some copper wire from wherever you can get it from. Thickness, as long as you keep it below 1.6 millimeters, you should be fine. I think this is just over 1 millimeter thick. And for the reflector, we're going to be using the lid of this cookie tin. This is just some tin that I've got lying around, nice and thin, so we can use scissors to cut it out. Now, when you're cutting this tin out, you want to be really careful because it is sharp stuff. You can end up cutting yourself on it quite easily, but what you want to do is cut it out roughly first, like I have here. Get rid of all that excess then, and then you can concentrate and cut a lot more accurate up to the line when you've got rid of all the unwieldy stuff. And now that we've got rid of the majority of it, we can take our time and do a better job. Next, we're going to modify our 4-hole SMA connector here to connect up our main driven elements that we're going to be building in a minute, and also connect it to the case itself. You shouldn't have to modify this like this, you know, if you can get hold of SMA. But I've got a piece of brazing rod here. It's 1.5 millimeters thick, pretty strong stuff. Any kind of copper wire really, but you want something probably a little bit thicker than what we're going to use here for the main driven elements, just because we're going to be using this to hold everything together, as it were. You can get away with using this stuff, but this just makes it a little bit stronger. So what we're going to do now is solder in a second length of this wire through one of the holes that we normally mount it with a screw. We're going to solder it in place like so. So we've got 2 wires sticking out, one from the main driven element in the center connector of the SMA, and another ground wire coming up like so. Now, as with any soldering job, preparation is key, so I'm going to pre-tin the hole first, and then pre-tin the wire that we're going to be using to offer up through this hole here. So now that we've got both surfaces pre-tinned, I've got the SMA in a vise here, so you can see. So I've got my 2 hands free. So a little bit of heat in there, get that flowed solder flowing, and we should be able to make these two together quite nicely. And to finally prepare everything here, I've got a little bit of heat shrink tubing, around 10 millimeters long, no more than 10 millimeters long will do it, because when we connect this to the tin that we've cut out for the back reflector, we don't want this leg making contact with that back reflector. We want this leg to make contact with the back reflector. So the next step is I'm going to use my SMA with the 2 legs on here now to mark where I'm going to drill 2 holes to fit these 2 legs through onto the opposite side of the reflector. So I'm going to line it up about in the middle, again using this hole that I did at the beginning just as a guide, and just put a couple of dots where I'm going to make the 2 holes. Now next I'm going to cut away this centerpiece that's on the CD spindle here. I'm going to use the Dremel with a cutting wheel. Don't try and break this off, because the plastic will crack and just tear a big hole in the middle. So just take your time. If you don't have a Dremel, then you know, use some kind of junior hacksaw, something like that, just to saw it off, and then file it down again with a Dremel, or just with a sandpaper block to make it nice and flush. Now that we've got the back reflector prepared and we've got rid of that centerpiece there, we can now permanently fix the back reflector in place. Now, I'll put a link to the original video in the description. Fox originally used some sticky aluminium tape. Now, I've used that before in builds. It's nice, but as I've shown in you know, over the years, that aluminium tape is nowhere near as good as a piece of tin like this. You're going to get a little bit more gain out of using a piece of tin like this rather than aluminium tape, but you can use aluminium tape if you like. You just need to have some kind of tab in there that you can solder onto, but this is just really easy. Now we're going to stick this down with some epoxy. You can use double-sided tape, anything like that. I'm even going to leave the masking tape in place to give it a little bit more grip to grip onto, but you can see, get this in place, get it fitted down inside there, and we've got the 2 holes there ready to accept the SMA connector. I just need to fit my SMA connector through here with the 2 legs, and then solder this leg here directly to the back reflector. This one's isolated, as I've said previously, so solder this one into place, and then to add a little bit more strength to the SMA connector, I'm just going to put some epoxy around here. I'm not going to use any screws or anything like that. The SMA is already grounded to the back reflector with this leg soldered in place. So to start off with then, with the wire, I'm just going to put a right angle bend in there. I'm not going to need the entire length of this. I'm probably going to cut it off much shorter, but you know, we can easily cut that away at the end. And I'm going to start building off this first right angle bend. I've got my measuring tool here, and I'm going to butt it up against that first bend, 31.5 millimeters. Use my needle nose pliers. Fiddly to do this on camera, but you get the idea. Put that up against the measuring tool, and then I know that this is exactly 31.5 millimeters in length, and I can put the right angle bend in there. So I've got this kind of shape going on, and that's how we start off with the first element. And then we just start working off each bend in turn using the measuring tool. Get it buttered up along there. My needle nose pliers, like so. Get it all nice and tight. And we know that this is 31.5 millimeters, so it makes it really easy. Now, if you're not used to building biquads, what I suggest you do is get yourself an image on your phone or your laptop and just have it next to you, and then you can follow along using the shape. It makes it much easier, especially if you're not used to making so many biquads. Makes it a lot easier as well if you're making a double biquad. It's easy to get it bent the wrong way around, for instance, but using this method makes it really easy and quick and accurate as well. You can make mistakes using a ruler going in there one at a time, but as I've said in the past, the biquad is a very forgiving antenna. You know, if you're off a little bit, don't worry about it too much, because it's something about this particular antenna, it just works, it really does. And the last one can be a little bit fiddly. But you can always straighten these elements up after you've got your basic shape sorted. So we're getting ready to solder the elements in place, and I've built thousands of these type of antennas over the years, and it's just suddenly come to me a new idea to help you solder this in place. One of the trickiest things with this biquad element here is soldering these two legs together. Because they're springy, they want to spring apart. It can be a little bit tricky, but because we've got our two legs on our antenna already, we're not going to use this length here like what we normally would, because we don't need it. So what I've done, as you can see, I've got some masking tape here holding these two legs together so they can't spring apart. I'm going to tin up in this position here and put some tin in this position here and solder it upside down, and that way should be a lot easier. I can just trim away this at the end, and we haven't got that messing around where these two legs want to spring apart. Now you can see the two legs there, and I've trimmed them down to 15 millimeters, so they've got a 15 millimeter height over this back reflector here. Try and aim for 15 millimeters. If you get it between 14 and 16 millimeters, that'll be okay. So always try and aim for 15 millimeters. I'm just going to pre-tin the ends of these legs up now, just like I have the biquad element, so we can solder it in place. Now, I can't believe I've never thought of doing this before. It makes it a lot easier to solder this in place. Now, because I've tinned everything up, I've just got a little bit of solder on the end of my iron, so I just need to get some heat in there and get that solder to flow. Now I've got that one in place, just spin it round and do the same to the second one. And because I've got this length to hold on to, I'm not going to burn my fingers like I would normally do doing a biquad. And last but not least, what I'm going to do is paint the lid, and I'm going to paint the lid on the inside. That way you don't get any scratches on the outside. So let's give this a quick test then. I thought I'd do it blue instead of having it all black, but I just didn't quite have enough blue paint to put a second coat in there, so it's a little bit translucent, but yeah, it looks pretty smart though. Now, a very simple test here on the bench. I've got an alpha card. At the moment I've got rubber duck antenna omnidirectional on there. It's 5 dB. That's also an alpha networks antenna. Works around 5 dB, as I say. So I thought what we'd do is give it a scan with that first and see what it can pick up, and it probably won't pick up many. If I elevated it a bit more it probably would, but we are quite isolated here. And then what I'll do, I'll swap it out for the biquad so you can see the difference. But what I want to do as well is pick on one particular access point just to see you know, what kind of gain difference that we get from that, because quite a few access points will pop up when I put the directional one on, but we just want to see what kind of gains we get from a particular access point. So let's give this a scan then. You can see we've picked up a few. The 97% one is here in the lab, so we can kind of ignore that one. And we can see the access point garden there. It's now kind of settling around 64-65% from its initial 73%. We'll just let it settle a little bit more, and that's the one I want to pick on to compare. Dropped out there, but it should come back. So let's swap it out now for the biquad and see what that can do. And I know that the garden access point is facing in this direction. Let's rotate that a little bit. And there we go. We can see that the garden access point is up into the 80%. We're also picking up many more access points, but a few of them are dropping out here and there. But if that was an access point and you were on holiday and you wanted to connect to that, so say it's a free one, you found it with your omnidirectional antenna, then you use something like a biquad, a directional antenna, to connect to it, you know, with a little bit more signal strength there, you'll get a much better speed and a much better experience using that internet connection. Anything below about 70% on the signal strength, you're not going to get you know, a particularly good connection if you're using the internet. Probably just a quick look at your emails will be fine, but anything else is just going to be really slow. So there you can see the difference between a 9 dB directional antenna and a 5 dB omnidirectional antenna. Now, as you saw in that video, this really is a solid performer, the single element biquad, and I've said to people in the past in the comments and in previous videos, if you're new to antenna building, make sure that one of your first builds is the biquad. You can't go far wrong. Even if you do mess up in some of your measurements, it still performs really well. And with this classic build here using a CD spindle, it's actually getting quite difficult to get hold of packs of CDs like this now. They are disappearing. But one thing I will say, which I didn't say in the video, is try and align your biquad so that something like this, where it's got lock and open to open it up, is at the bottom, and then that way you know that your biquad is aligned correctly, rather than having it you know, say cockeyed a little bit, and you don't know which way round you've got it aligned because you can't see through here. But yeah, if you make sure that's at the bottom, then you always know. But yeah, quite clearly in that test, compared to an omnidirectional antenna, the single element biquad really is a sound performer. And this is something else that one of the subscribers, a supporter of the channel, has sent me. He sent me 5 of these that he printed off on his 3D printer. I don't have a 3D printer, but apparently now I've searched since getting this. This is quite a common design. You can download it off the internet, quite a few different forums and websites. And it's like a little spanner for the SMA connector, because you haven't got a lot of room here at the back to screw it into your alpha card. It is simple to do with your fingers, but it can be fiddly. This is like a little spanner, and it fits over the top there and allows you to screw it in. It really is ingenious. Whoever come up with this, the first person to come up with this, I don't know. It's quite a few people making these, but yeah, keep your eye out, have a look on eBay, see if anybody's selling these. If you don't have a 3D printer, they really are useful things to have. So hopefully you enjoyed this video, and I'll put a link to Fox's original video down below. You probably see a little bit of difference there between my measurements and his measurements that he states in his video, but that's you know, one of the things 15 years later, and I've got a network analyzer and a spectrum analyzer. They're the measurements that I use that you know, work for me. But 31.5 millimeters single element biquad, really useful thing to have. So if you did enjoy the video, please give it a thumbs up. Comments or questions, drop them below. I'll do my best to answer them. And if you want to learn more about this kind of thing, pop along to over on Facebook to the antennas group there. It really is growing, and there's a lot of people on there, especially if you're interested in the LTE, 3G, 4G and now 5G. A lot of experts on there now that can really help you with those kinds of antennas. But hopefully you did enjoy the video, and hopefully you'll join me on the next one.